Good day everyone. In our previous lecture, we looked at the role that a motor plays in a drone. However, there are different types of motors that are available in the market. In our present lecture, let's look at the two types of drone motors. For beginners, there are two types of drone motors which are used, brushed and brushless motors. They vary in the way they work. The brushless is way more powerful for their weight than brushed motors, and they last way longer. For bigger quads, no question, brushless is king. But for the micro and nano drones, it's fantastic to have these cheap drone motors to crash with confidence. The internal workings of a brushed and a brushless motor is the same. Both are based on electromagnetism. When the motor windings become energized, both the motors have coils. A temporary magnetic field is created that repels or attracts against the permanent magnet present inside the motor. This magnetic force is creating the repulsive force in the coil that is used to spin rotate the shaft. Let's begin with looking at details of these types of motors and the difference between them. The internal operation of a brushed motor is contrary to that of a brushless drone motor. In the brushed motor, the stator provides a permanent magnetic field that surrounds the rotor. The rotor of the brushed motor is an electromagnet which is influenced by the surrounding stator. A pair of brushes attached to DC power contact the commutator ring at the base of the rotor. The commutator ring is divided, therefore, its rotation will periodically reverse the direction of the current flow through the rotor as its rotation causes the commutator to reverse its polarity. The alternation of the commutator ring polarity translates into uninterrupted revolution of the rotor. This entire process occurs internally within a motor, which provides excellent protection for the delicate components. Although efficiency of the system is reduced due to the greater thermal insulation of the internal mechanics, it is possible to reverse the rotation direction of the motor by inverting the polarity of the DC power output. Due to the contact of the brushes with the commutator, longevity of the brushed motor is greatly reduced in comparison to the brushless motor. In terms of application, a brushed motor is better suited for micro class multicopters. Their small size, low weight, and simple driving techniques improve their suitability for micro drone flight. As the name implies, a brushless drone motor lacks brushes. The brushless drone motor can be effectively divided into two separate components, the rotor and the stator. The stator is the central unit into which the rotor is mounted. The stator is made up of a network of radial electromagnets that alternatively power on and off to produce a temporary magnetic field when a current is passed through the windings. The rotor holds a collection of permanent magnets which are positioned in close proximity to the semi-permanent stator electromagnets. Attractive and repulsive interaction of the stator and rotor magnets is translated into rotational movement. When assembled, the shaft of the rotor is inserted into a pair of ball bearings located in the stator that maintain linear, smooth revolution of the rotor. Although the brushless motor is powered by DC current, it can't be driven directly. Instead, the brushless motor is wired to the control electronics, effectively eliminating the need for brushes or a commutator. Longevity of the brushless motor is excellent as there is no physical contact between the rotor and the stator. The brushless motor is also more efficient than the brushed motor. The brushless motor is extensively used in mini and some micro multicopter applications where high power outputs and efficiency are prioritized. What is the difference between brushed and brushless motors? Efficiency wise, Brushless motors are typically 85 to 90% efficient, whereas a brushed DC motor is only 75 to 80%. Windings are present on the motor for a brushed motor as compared to a stator for a brushless motor. This difference in efficiency means that more of the total power used by the motor is being turned into rotational force and less power is being lost as heat. Brushless motors last longer because there are no brushes to wear out, while the brushed motors wear out quickly. That's one of the reasons brushed motors came out cheaper than brushless motors. The size of a brushless motor is identified by a 4-digit code that details the dimensions of the stator in millimeters. For example, 2206. The first two numbers in the series determine the diameter of the stator, in this case 22 mm. The final two describe the height of the stator. The last two numbers in this series are 06. Therefore, the stator unit is 6 mm tall. It is important to remember that these numbers do not describe the external dimensions of the brushless motor itself. The size of a brushed motor can be identified through a simpler two-number system that clearly defines the diameter and the height of the exterior in millimeters. For example, 6 cross 15. The first number 6 is a measurement of the can's diameter, and the 15 inches is the height of the can. What kind of motors do drones use? Most of the drones use brushless motors. Most motors on quadcopters are outrunners. In outrunner motors, the rotating part is on the outside and not the inside, as opposed to the inrunner motors. Because of this layout, this type of motors can generate much more torque. High torque is required for quadcopters since you balance by changing the revolutions of the motor. The higher your torque, the faster you can change the speed of your propellers. High torque also means you don't need a gearbox and saves a lot of mass. Outrunners are not very practical for brushed commutation, as it would require lots of wires and additional contacts. Hence, most of the outrunners are brushless. To summarize the lecture, we looked at what brushed motors are, what are brushless motors, difference between brushed and brushless motors, and what kind of motors do drones use. Once we have looked at what type of motors to use, let's look at the selection criteria of these motors based on the requirements. In our next lecture, we will look at how do we select a motor for a drone based on our requirement. Thank you very much.